As this is early in the morning, we slowly start by reviewing. It's good to review a little bit. Everyone was very tired. I look at every classes. Every class is like we're tired from the midterm. We're tired for everything. So I just uh try to not to go too very fast. But our goal still today is to finish this set of slides. As you would see, the assignment has been released already. I mean, you can check it out, but we'll talk about this again later because people are coming. So I just slowly review in case you has not very fresh your mind enough. So get some exercise in our mental exercise. So let's see. So just we're beginning again. The random variable is the way you put numbers to outcome of the random experiment. The reason why you have the number there because of this is the only thing you can measure, or this is the only meaningful way to put number there. Okay. And in our discussion, as we said, we focus on numerical variable. And that means that numbers can add and subtract. So all the calculation can be done. And we focus on two cases based on the math tools to be used. One is called discrete, the one is continuous. And discrete would be the one that you can use standard math. Continuous, you have to use calculus. And for discrete, we have two ways to describe. One is big P. Big P is you give me the value of the random variable, I give you that probability. And the big F is just the probability less than equal to that value. And you do know, remind you that you can always convert P to F and F to P. Then always you can do this one way over the other. And after that, then we learn two ways to summarize, one way, to summarize the P, because P is complicated. That is expectation, which essentially is the mean. If you repeat this experiment many times and you get all the outcomes, and you convert all the outcome to the numbers through random variable, okay? And the variance would be the same idea as you had all the data, then you would just have how the number varies, and you learn the property of the mean and variance. You will be using some of them in your assignment, right? How to calculate the variance, right? And when you multiply or when you add. And after that, we also briefly cover what we call bivariate random variable, which essentially is you use two numbers to represent the outcome, right? And that leads us to define what is the expectation, right? When you have x plus y is sum of the respective expectations, and same as variance, okay? And you have the covariance as well. And there are 5 different distribution, and then actually you will be working on them in your assignment, right? You will see the binomial, Poisson, hypergeometric, okay? As we said in the class, right? We will tell you which distribution you're going to use, right? But in the application, you have to decide which one would better fit your case, okay? It's your job to decide which one fits better. And how do you know which one fits better? And then there's some assumption behind different distribution, then you think that fit better, then it's the case, right? So uniform will be the case where everything is the same, right? And Bunoni will be saying that you have a binary view of the future the future can be considered as either success or fail, and you know the probability of success or fail will be P and 1 minus P respectively. And you also see the Benoni, they have the mean and variance, right? There's a formula there. After that, we build up from the Benoni, we build a binomial, right? You repeat this Benoni n times. Essentially, you're saying that you open n different boxes, and each box only have two outcomes, and you have success is P and fail 1 minus P, and then you care about number of success. Okay, you don't care about the order success, only the number. And in that case, your life is very simple, right? Will be the just NCX, right? PX 1 minus P raised to the power n minus x. Okay, this is the P function, and then the mean and variance. Okay, it will be just because it's independent, so some of the mean, right? Some of the expectation of some expectation, same as the variance. So that is coming directly from the Benoni. And an example of how to use it, right, is just like if you consider that each customer will have 30% of light spicy food from a data, right? So then this is the good way to model it as binomial. And if you consider the case where given a period of time, right, how many people would come, then it will be a Poisson, right? The Poisson would be just a case of binomial when n is very large and p is not large enough, not very large. P is very small. So we have this formula and mean and variance the same. And in the case of hypergeometric, we are asking ourselves is we have many n boxes to open, small n box to open, but the fact that each box is not independent will give you hypergeometric in the sense that you have fixed number of good item and bad item, right? And you open n of them and look at how many of them are going to be good, right? So that would be the question, okay? And you know this P function is a fraction of combinations and then the mean and variance as well. And it's very useful if you study accounting or you want to do quality control, okay? And this is something that very useful one, okay? Of course, as we said, if you have a very large sample size, very big n, so the big n is relatively very big, right? Then the binomial and hypergeometric will be very similar. Okay? You can actually show that, but we're not math class, so we don't really worry too much about this point. And after that, we get to our continuous random variable. And our beginning motivated example would be saying that P is not well defined, the big P. The reason is there's no single number we can assign to each value of the random variable because you have continuous means that you have infinite many points that the data can take. If you put anything that is non-zero, adding infinity of them will be exploding not to one. Okay, so it must be zero because you can't say anything. So that's why the example will be like this, right? If you from 0 to 1 and then you have infinite many, then you will have 0. Okay, and that's why you have to use the big F for your continuous random variable to describe it. And for the purpose of our class, if F is smooth, the big F smooth enough, you have a small f, right? By smooth enough, that is actually mean differentiable if you learn calculus. And that means that we will look at the area under the curve of F will be the big F. So this is easier to see what's going on. So to remind you, this is the result from calculus because it's always possible to find a function f to small f to represent a big F. that is as long as it's defensible. Okay. And the expectation and the variance, same idea as a discrete, which I'm not going to repeat. And you will see the same math, the linear property, and the quadratic idea about the variance all hold the same. Okay. And we'll finish all this and then go to some Excel. Okay. Very quickly. Okay. So just to quickly review the uniform exponential, we go to normal. Okay. Uniform will be just every value. Of course, we have probability 0, but every interval, okay, of interval of the same length with the same probability. Okay. So that's why the f function is a rectangle, because as long as you pick the same base, okay, the height is always constant. So that's why the probability between an interval have the same width, okay, will be have same probability. Okay. Say the probability that the random variable is between A to A plus 1 or B minus 1 to B, they are all having the same probability, right? Because you only rely on the length of the interval. Okay. And you can always go from F, small f to big F, right? By looking at the area, right? Because pick a particular point, the area will be the base times height, x minus a times 1 over b minus a, and that will be this function f, right? Just to remind you, this function, probably I didn't write down here, but this is simply x minus a over b minus a, right? But I didn't. Maybe I should have written down here, right? And this is a linear function, right? Fx is equal to mx plus c or ax plus b, if you like. And this is the uniform. Okay. And of course, for those of you who worry about this, is I'm not asking to derive this formula, okay? Since I didn't put it in the main slide, right? But the technical slide is already exists, right? How do you show it? I mean, we did have there, okay? And you did know this the mean and the variance formula. Then what is the mean will be the 2n's over 2, right? Variance with the range square over 12. There's something that you may want to pick it up when you do the calculation. We're going to give you the example to calculate mean and variance, which I'm not going to repeat, and probably the same. I'm not going to review that part because I think we reviewed many times already. So the exponential is the idea of you get a Poisson, right? The Poisson probability is asking within a period of time how many people arrive. Then the exponential, the time it takes for something to happen, right? Time, and in this Poisson idea. And the important part of this is exponential, which means the function look like this style is decreasing. Okay. And just to remind you, the exponential is this waiting time would be have a particular feature called the memoryless, which means that no matter how long you wait, okay, you don't change your mind. Okay. Okay, so that probably may not be the best case in the business world, right? Suppose you have waited for your delivery for 1 hour, right? Then the probability that the next minute will come, right, should be higher compared to the case when you try to order it initially, right? So you should expect that this might not hold in business world, but you do notice that this going to hold in the physics world, right? That means that if you really want to apply this to many business cases, then you have to use a more complicated one, right? Poisson is still fine. I don't think that's a big issue, but exponential may be a little bit easier when you try to think how to actually apply in the practice. But of course, it's still a good thing people use it. But if you want to really want to apply things to model waiting time, then you want to get a more complicated version of that. And there's a lot. You can go to Wikipedia and check there are at least more than 10 to 15 different type of style of waiting time. But it's way beyond the scope of our class to cover it. But shouldn't be an issue for you to check because you know, right? Once you know how they derive this, you think it fit your application, you can just apply it, right? This is the model. It's not something complicated to see. But if exponential is a good match, then that would be the case, right? So the time until our next classmate comes in, right, should be follow exponential, right? I think, right? Because I guess many of you are coming due to different reasons, maybe have delayed the school bus or the bus taxi driver or the canteen lady doesn't give you the food, right? You have to wait a little bit and here and there, right? That's yes, we have exponential comes in. So I think the next guy would come in is also follow exponential, right? Maybe I should close the door a little bit. Otherwise, I would just keep barking over. Now, go to normal. That is our main goal today. I guess many of you are here, so I can start the real business. We start reviewing. So, normal, what we are doing, normal is very important because I said this is we will rely this for the rest of the semester. Okay. And normal is the only distribution you learn that cover everything there, means every number, negative, positive. Okay. And later you will see the bell curve is so robust. Okay. It's so strong. Yeah. Exponential. Okay. It's a strong that no matter how you add, subtract, multiply, then it's still a bell curve. Okay. We'll talk about that. That's very robust, very strong. So this is our role model, right? And no matter how much thing you do it, then it's still a normal. You will see very soon. The normal will be featured by two number, which we call mean and the spread. Okay. Mu is controlling the center of the distribution. Okay. And the sigma square is controlling the spread. Okay. So if you change the mean, mu, it's moving around. Change spread, it just go up and down. It's spread out. Okay. And that is the two parameter there. Okay. And do remind you what is this kurtosis and skewness that we learned. The skewness is 0 and kurtosis is 3. Okay. That is we cover that. And the reason why we only talk about the normal, because normal is so common, and actually you can calculate kurtosis and skewness for all the other distribution, because every distribution you can calculate skewness and kurtosis. So it's not just only for normal. Okay. And the shorthand for normal will be the snake or the snail means follow the distribution or distributed as normal, mu, and sigma square. And here is the first thing we will call the robustness of normal is you actually multiply and add is still a bell curve, which is, as I emphasize again, this is usually not true. Okay. In general, not true. And it's not true for everything you learn. Okay. For example, it's a uniform distribution. You multiply, but it's not uniform anymore. If binomial, you add something, it's not binomial. You add anything in Poisson, it's not Poisson, right? Because Poisson from 0, 1 to 3, right? You subtract is also not Poisson, right? Become negative. Same as hypergeometric. You multiply, add, or subtract is no longer the original shape. And the robustness of this normal is no matter how you add, you multiply, can be negative, can be positive, right? I didn't say about A. A can be any number, right? Positive, negative, fraction, integer, whatever you like. It's still a bell curve. Okay? So just to remind you what am I saying, again, graphically, like this, right? You have a bell curve. Okay? It's a bell, X, right? Mu sigma square. Okay? And instead you consider another one, which is AX plus B, right? So what means, suppose A is 2, right? You have a number there, okay? You will multiply by A, right? Suppose this is called 3, right? There will be 3A plus B, okay? So every number you just multiply by A and plus B, right? And then the question is, will it going to be different shape or the bell and turn out to be surprisingly bell? You do this kind of operation, it's still a bell, okay? I mean, you already know if you do this, right? The expectation of AX plus B is still always A mu plus B, right? The variance of AX plus B is still will be A square sigma square, right? So that's not a big deal, okay? The only thing is the bell curve, okay? And it tells you that not only this is true, it's still a bell curve, okay? So that is, I would say, is pretty surprising. Now, once we know this, then we go back to our model, and probably that is the reason it's so robust. As we said, that is the reason why you see normal that often. Okay, but we will have another explanation very soon. Now, because of the A and B arbitrary, we can make A 1 over sigma and B mu minus mu for sigma. That means that if you do that, you can always transform the X normal into the standardized version, which is mean 0, sigma 1. Okay. And if you do this, what is the Z represent? Z is just saying how many standard deviation is above the mean, right? If Z is 1, it means that it is 1 SD, standard deviation above the mean. If negative 1, if 1 SD below the mean, okay? So that is very important. And why? Because I think we covered last time is how to check the table, right? The table tells us how is that f function, right? The table gives you the f. It's looking at the if you look at the small f, will be the area below the curve on the left hand side. So if I want to know the probability less than 1.4, right? Simply I go to the table, right? And look at 1.4 will be this number. Okay. How to read this table? This table you always read from the first column. You pick the number there, right? 1.4, and the entry table will give you the big F, right? Remember, this table is giving you the big F. Okay. Big F is what? Big F is the area under the curve of small f and on the left hand side. So it will be like this. I wrote in the first diagram, right? Look at 1.4. Look at the number all the way from the negative infinity, right? So this is the probability that the random variable of the standard normal is less than 1.4, okay? And you can calculate that actually means what? If you have a normal distribution, which is 1.4 SD, right? So just asking if a normal distribution if is above what is the probability that is below 1.4 SD? That would be 91%, right? So that would be what it's saying if you convert back to the standard case, okay? So you can say the same here. What is Z less than 1.6, right? That means that asking us is the probability that the random variable normal is less than 1.6, okay? That's a good one, okay? And if between two numbers, then you will be just taking the 1.4 left-hand side, the blue one and the red one, and the difference between blue and red will be the purple, okay? Now, once you know that, then we will do this very important rule, which we stopped last time. It's called the 2 sigma rule, okay? This 2 sigma rule is, I think, this something should stick in your head. I mean, probably you will, because we'll be doing this throughout our semester, is saying the following. Suppose we have a normal distribution, which is something that actually you would have in your head, right? If you have nothing to suspect, either you do the uniform or either you do normal, right? That is the two things that you will be doing the modeling, right? If you don't have any idea what's going on, normal or uniform will be the thing that the easiest candidate you want to do, right? Just like if you don't know what to give to your girlfriend, right? Either flour or chocolate should be something that by default, right? If you don't know what to buy, right? Or a handbag should be okay, right? That's something you know. Or you don't know what to buy for your boyfriend, right? Then you buy a bell or buy a display card would be okay, right? But anyway, so what was that going on here? This is saying that if I have normal, it will be within 1 SD from the mean with 70% or 68. Will be within 2 SD, will be 95%. Will be 3 SD is 99%. Okay. And how can I get those numbers? And that is directly from the table that we have just saw. Okay. Let me illustrate how we get the first one. Okay. The first one means what? The first one means the following, right? The first one is, this is 0, Z, okay, is saying that between 1 SD, okay, the mean is between 1 SD, have 68%. Okay, this is what it's saying. Okay, how can we solve it from the table? So we'll show you that the red area, which you can read from the table directly. Okay, you can read that. Which this is what this red is f of 1. Okay, and look at the blue area, which is f of -1. We can read that from the table. Okay, and you subtract f of 1 by f of -1, then you get the green area is 0.68. Okay, let's see what is f1. F1 will be this number. 84% is F1. Okay, so this is 84%. What is f of -1? Okay, let's go again. Is 15%. Is here 15. So let's go back to here. So this is 15%. Okay, you subtract 84 to 15, then it's 68 or 69, right? So that is how I get the 1. You should go home if you want to test yourself whether you understand. You should be able to show 2 SD should be 95, 3 SD should be 99. Okay, you should ask yourself if you understand what's going on. You should be able to derive yourself. Okay, if you're not, then ask me. You can check this during the break. Then if you want to make sure you understand, but rest assured, you will be given homework. You can do. You already know there will be one. You can have fun. Okay, you will know. We'll be doing this all the time in this during this semester. So Don't worry about that. We will have fun on this. So I hope this helped you to understand why we have 3 sigma rule, right? So everything should be within 3 sigma or 2 sigma. So what is the application of this? Okay. Although we don't have midterm, but this is, many of you have midterm in many classes. And suppose the midterm, you get 90 points, okay, out of 100. Is it good or bad, right? Then the question would be, depends on how well you're doing compared to your classmates, right? And if you are, the mean of the class is 80, right? The SD is 5. Maybe I write that down, right? That will be easier to demonstrate the usefulness of this. Okay. So you have a midterm. Just to emphasize, again, we don't have midterm in our course. Okay. Midterm, all right? So you have 90, right? Is it good or bad? Okay, the question. And professor said, okay, the mean of the class X bar is 80. Okay. The standard deviation SD is 5. Okay. How well you're doing. Okay. You remember you are actually doing pretty well, right? Because remember, even though if you don't want to use the C table, you know that you are 2 SD above the mean, right? So you know that 95% is above 2 SD, right? And then you are at least top 5%, right? But to be exact, is top 97.5%, right? Why? Because you can imagine here, Z is here, right? This is 0. You said 2SD is 95%, right? That's the rule. 95, which means that this area and this area add up to 5%, right? They're symmetric. So 2.5, 2.5 here. So if you're 2 SD, you are 97.5%, right? So if 100 people in the class, only 2 people better than you. Okay, you are the top 2, the third guy. Okay, so that means that this can be easily done. Actually, in this case, you're very good. Okay, if the score follow normal, right? Okay, so that's how you would get the idea. Okay, and okay, I hope that would help you to see why the 2 sigma rule is very important, right? Because you can easily, without looking at the table, right, so try to look at how many SD you are, then you can, out of the head, can tell you how well you're doing. Okay? So you can ask yourself, if you are 95, what happened to you? If you are 85, how good you are? If you are 70, then how good you are, right? So if you're 65, how good you are, right? So that all the thing can be answered using the set table or using the simple rule, then you can have a good rough estimate of what's going on there, okay? Now here is the inverted normal, which is asking you to read the table reversely, right? Remember the F table is going to do the following, right? F table is you, this is small f, right? This is Z, this is 0. The small f is asking, so big F, the F table, the Z table is, you give me number A, okay? I give you the area of this is F of A, right? It's the area on the left-hand side of the small f, okay? You give me the thing at the bottom, I give the area, okay? This is the standard. But sometimes we care about the reversely. I give you the area, I want to give you what number it is. Okay, I give you f of a, and I want to know the a. Okay, so that is something that I do this kind of calculation all the time, as we emphasize in the uh, second half of the semester. So this will give you this number. I want to go back to a. Okay, before we go the one way, but now we go the other. This is called the inverse function. Okay. Now they give you the example of how we do it, right? So we have asked ourselves, what is the number z such that z less than z is equal to 0.95. So if you want to know this, essentially the question is like this. The normal, z is here, this is 0. I want to know a number z here, okay, such that this area is 0.95. Okay. And how you do it, you just read the table, because our table is area on the left-hand side. I'll try to look at the table. The entry is closest to 95%. Okay, because you read it from the other way around. How do we do that? Let's actually read the table. Go back, go back, go back, go back, go back. Now, almost. Okay. On this 169 slide, we've tried to find something is 95%. Looking around, scanning, it is turned out to be somewhere on the row of 1.6. Okay. And the column of 0.404 and 0.05. So that's you get 1.64 and 1.65. You can do the midpoint 1.645, or any number will be fine. You can put 1.6 or 1.65. It should be fine for our class. Okay. You don't have to put 1.645. I just do the middle, but you can do any number in between. We'll get a stamp for you to put it correct, right? Because at the end of the day, you will do Excel, right? Later it will show you. But if you do a table, we allow you have margin error. As long as your answer is anything in between these two, we'll get you a free pass for that. Okay? Is that okay? Okay. But when you do an assignment, you can have use Excel. Okay. So later we tell you what is the Excel function for this. But I hint it for you first. This function is called, later you will see, we'll talk about this after the break. It's called the norm standard dist. Okay. This will be the function that we'll talk about that's at the end of our class. Okay. This is the Excel function that calculate all this table. Okay. It's already in your slide already, but at the end, the very last 50 pages of slide. Okay. Now, once we did that, we are ready to go to the business of this normal. Okay. And the question will be like this, right? We're asking ourselves, okay, we have normal now with x is here, sorry, right? With mu 20, sigma is 4 because sigma square is 16, right? Take a square root, right? The bell curve is like this, okay? The question is asking us, okay, what is 16 is here? Probably less than 16, so this area, right? This F, right? This F, right? Or asking what's probability that the normal distribution, right, for the random variable following distribution will be probably that have less than 1 SD, right? Because this is actually 1 sigma here, right? It's 1 SD, 1 SD, 1 sigma, right? And this is essentially, if you look at it, it just 0 is here. This -1, okay? Is same as this area. The same thing, right? It's the same thing. The error same. Okay. So just 1 SD It's just -1, right? So find the error and find this area is very simple. Just go to the table, look at Z equal to -1, okay, which is 15%. We found that already, right? So that will be done. So how do you calculate? So for every normal, you just convert to the Z, right? Look at how many SD is below the mean, then we're done, right? That's what we're doing, right? For every normal, we just look at how many SD below the mean or how many SD above the mean. Then you go check the table, then we are done, right? So that is always the same standard procedure. Okay? Is there any question? If no, we go to the other example, which illustrate this is how I do it, right? In the graphics. And the other example is asking, okay, now we have mean 20, right? This is X, right? The normal here. Okay. And I have 24. How likely it's more than 24, right? And we know that, again, the sigma is 4. So it just, again, just 1 SD. Okay. For 1 SD means if you convert to Z, 0 is here, right? What you are talking is 1, this area, right? Because it's 24 is 1 SD, right? Because SD is 4, right? So it's just asking this one. And how do you do this? The blue area. Remember the area under the F must be 1. And the table gives you the area on the left-hand side. Okay. And you subtract that, right? The complement rule, as we said, right? Subtract that, you are done, right? And we know that it's already 84, right? This the left-hand side 84, right? You can check the table. This guy is 0.8413. In case you don't know, I check that again for you. You go back here. 1 is this guy. Okay. 0.813, 0.8413. Okay. So once you know the area green is 0.8413, then we're done. Right? Because 1 minus the green is the blue, right? Because the total area under the F must be 1, right? Because it's probability, right? Because it must be come out some number, right? From negative infinity to positive infinity, right? Must be some number, okay? And so that is the graph I show you. You get the blue thing, subtract on blue, get the orange color, okay? For 16 to 24, the same idea, right? Because 16 to 24 is actually 24 is 1 SD above the mean, 20. 16 is 1 SD below the mean. So actually, you don't need to calculate because this is the empirical rule, will be 68%, right? We learned that already because this is just the rule, right? It's the 1, this is the 3 sigma rule, right? And here's a 1 sigma, right? 1 sigma rule here. And of course, you can do the calculation, already show you already at the beginning when we talk about the Z table. Is that okay? So this is all the calculation we need to do. Now, before the break, I want to tell you the last thing we want to know. The normal is how robust is it, right? Before I said you take a normal, you multiply, you add, it's still normal. The bell is so strong. Now we tell you that the bell is even stronger than you think. The question is following. If I have 2 bell X and bell Y, okay? If we combine the 2 bell by adding what we expect, is it going to be a bell or not or something else? What do I mean by that? Let me draw it. Suppose I have a 1 bell here. Okay. Have mu of X, sigma X squared. Okay, mean and variance. Now I have another bell, much larger, maybe a little bit, maybe look like this, right? Much flatter. Okay, let me stand a little bit red. Okay, and the blue color. Okay, you can see the mean is much higher. The variance is different, right? It's much flatter. Now, suppose I draw a number from the orange bell, which X bell, and I draw a number from the Y bell. Okay, I add together. I add the value of two bell. What kind of distribution expect? Okay, what are you going to expect this guy? Okay, suppose I pick one number here, right? One number here, and pick one number here, right? Add together X and Y. You should maybe somewhere here, right? Okay, and I do this all the time. What do you expect? Okay, what is the line you're expecting? Okay, you may be thinking, okay, since it's like this shape, maybe something like this, right? Right? You would expect something like this, right? Because a lot number is smaller than the big, right? Just coming, you merge together. Turn out, no. Surprisingly, if you add these two bell, the answer is you expect it's still a bell. Okay, and actually it should be a little bit more, something like this, much flatter. What you get is you get sum of the mean, which is not surprising, and the variance is simply adding. Okay, it's much flatter. So this, with the result, the two bell add together is to a bell. And you can see that's the reason why you often see normal. Why? Why your IQ is normal? Why your weight is normal? Why your height is normal? Because of your weight and height are result of many things add together. And of course, you divide, right? And subtract, or right? Say your DNA is depend on your dad and your mom's DNA. Suppose you're human, right? You are not germs, right? Germs would be just multiplied by yourself, right? You self-replicate, right? But you are depend on your dad or your mom, right? And you are not 100% of your dad, right? You have 50% from your dad and 50% from mom, and which 50% depends on the random split, right? So that's why you have some diversity in human, right? It doesn't look like the classmates sit next to you, right? Even your sibling are very different. So not just adding, subtracting is also the same, okay? If you subtract X from Y, that you will be something as same, okay? So you will have the same idea. So that is the thing I write down in the slide, okay? You add, this adding the mean, adding the variance. You subtract, okay? Perhaps surprisingly, mean is still subtract, but the variance is still adding, okay? The variance is not reducing, it's still adding, okay? And you may ask why, because just variance is not going away, okay? Okay, so that is a graph I show you, right? You add and subtract, the variance still adding, okay? Because why? Because we didn't say about X and Y, right? Y can be negative and positive, right? And doesn't really matter, okay? So that is the thing we'll use, not in this class, but the next few classes, we'll be using this idea a lot. Adding normal is to normal, okay? Subtracting normal is to normal, and that actually form the basis of the analysis in the next class. We talk about data, okay? And in the meantime, let's have a break. And after that, after the break, we talk about mention a little bit about chi-square, T and F. We just mentioned what are they, because we will not talk using it until we're late stage, but we just talk that. So you will not see the assignment for the chi-square, T and F. I just put it here for completeness. I just mentioned a little bit, and up to here you can do the assignment already. Okay, just to remind you before the break is the assignment is already put in the if you notice it's already there. Okay. Okay. And some of you asked me the test last class. It's already there as well. Okay, it's last year ex exam question, not the midterm exam, is exam question. So last year I just asked 3 questions. Okay, 1 hour, 3 questions is not a lot, right? And then 20 minutes for each question. And question one, as I said, we are not answering any question on the assignment question until November, right? Don't ask me anything about this in October, okay? I just released earlier. So the first question, I think everyone sees very simple, right? Number there, I ask you Excel input to calculate this. Okay? So if you have your slide, just copy 1 second, then you're done, right? I'm not asking to calculate it, right? And second one is also, you know it by now, I hope, right? I tell you something follow exponential with mean this. What is the Excel input to calculate that, right? So if you know the Excel input, which we'll talk about after the break, then you're done, right? I'm not asking to calculate the direct answer, right? So if you bring your slide there, you know what the question asking, you should be able to do it. And as I said, our test is easier than your assignment, as you can see, right? It's not, I do not lie, right? It's actually easier than assignment. But as I said, the difficult part is not about the content. It's about whether you know the material, right? Then you can quickly figure out which slide you're looking at and then just copy it. And it's not something difficult. And question number C will be, I'm not even asking you to calculate, right? Just you write down the formula is, this is actually the problem actually you learn is the base theorem. Is box A and box B have black ball and white ball. You draw a black ball, whether from A or B, right? The same question. Okay, just right. You have team A have developer a designer, B has several number of designer and team. You choose a team and choose a member. If a developer, where it come from, you can see it should be more likely to come from B than A, right? But you have to tell me the calculation. You don't have to calculate the answer, but I need to see the formula to get it, then you're done, right? So if you forget your calculator, you still get full credit for everything, right? So you don't have to worry too much about the calculator thing. And question two, unfortunately, you don't know until maybe by the end of this month, you should be able to do it, okay? Kind of, you can see the bell curve idea, okay? Normal distribution, and then there's something else in the third question is asking you to do an over Excel problem, which is with a regression, but and that's it. So it's not something too crazy, okay? And do remember your assignment too. Will be due 2 weeks from now, and it just like 7 questions, and each question asks you to do the binomial, right? Poisson, hypergeometric, uniform, exponential, and none of them are beyond what we cover in the class. Okay, you can just see you should be able to do it without a lot of problems. Okay, as promised, we should have a break for 15 minutes. After that, we'll continue. In the meantime, please let me know if you have any question. So resume at 10:39. So let us slowly get back to see what happened. How do you cope with and continue to focus if you don't get enough coffee? Um, well, actually, it took me an hour from home to here, so that's why I always sleep on the train because I just too tired. I mean, because I taught like 8 hours yesterday, so 3 hours in the morning, 2 hours in the afternoon, and 3 hours at night. So of course I don't have enough sleep, and also my wife and my parents all got sick, so take care of the kid. I'm very tired, but coffee will be useful. And one way to do it is also meditation is very useful. If you can't really sleep, then probably keep breathing. Deep breathing is very useful practice, and you should try some mindfulness exercise. It's very useful to be useful. Um, and also, psychology is very useful at all. You tell yourself, don't too much stress. Actually, it's going to be helpful. Okay, and then telling yourself, you have to wake up and do the things is also very useful. And you see, I just finished a coffee, so hopefully that help a little bit. And also one thing, oh, by the way, it's also one thing is very useful as well is vitamin B. So if you don't have enough sleep, uh, and then you take one vitamin B pill. It's recommended by my cousin who is a pharmacist. And then when you don't have enough sleep, take vitamin B is very helpful to regain because you don't have enough sleep late, then you consume a lot of vitamin B. Well, of course, I'm not a medical doctor or whatever, right? So just check if this is right. But this I can tell from experience, that's what I do, okay? But doesn't it's not a medical advice or what, okay? Because I'm not eligible to give any medical thing, but I just my idea. Um, I don't think we actually do any normal distribution, but we use the criteria-based scoring. But surprisingly, even we do criteria-based scoring, uh, the way the student actually follow some distribution. It's not normal, obviously not normal, but it did when the class is large. You look at the data, it actually still follows some distribution anyway. So it doesn't see that we adopt criterion-based learning. A lot of people work very hard and people try to get an A. Doesn't work in this way. I mean, we hope that happen. I think the school actually happen. We don't have curving. We want more people study harder, get A, but it doesn't happen. I mean, still people want to study hard, study hard. Still want to lay back, still want to lay back. And I guess that also people in B school, right? Many people want to do intern, so uh, do other things. So we don't have to be in the red race. So I think it's good. How many students I give A? I think I don't. My class is. I think our class is large enough, so we are almost like following the average of in other class as well. Of course, naturally come from how we perform in class, and usually I think A will be like top 50-30%. And next 15-20% is A minus, and the next 40% is B plus, and B and B minus is the rest, I guess. Rarely I give C. Uh, uh, I don't fail anyone except someone who don't take the exam, don't submit any assignment. Uh, I don't know. I give him fail or he just drop out. He or she just drop out from the class. I can't actually recall, but rarely. I mean, as long as they're in my class, they do all the thing. I mean, uh, well, it's not that easy to get a C, but you can try. But so far, no one seems successful to get it unless he just missed the exam, missed everything, right? If he missed everything, I can't really say too much about him or her. But I think as long as you are in this class, right, physically here, then usually, I mean, B plus is the minimum thing you should get, right? But uh, unless you just really don't do anything for exam, don't do anything your homework, right? Um, Nothing. Tired. Uh, the C table, I think you just print it out, and some of you ask me in the lecture slides. We have slide number 9 is actually all the table you need for our class. So you can bring, for the convenience, you can bring this to exam theater. It contains everything we need, I guess. Okay, it should be sufficient. As I said, right? If you don't know, just later you write the Excel function. Okay, I think we should give you the credit for that. Okay, if you really need that, okay, or almost full credit. Okay, if you don't have the Z table, you just give me the Excel function, we should still give you almost all the credit. Okay. Uh, yeah, I think. But my daughter said I look like a high school kid, so with this, so I don't know. With the white t-shirt, so everyone know it's Friday. That's good. The weather we don't have consensus. The key point is normal. Okay. Yes, if you're two SD above, if normal distribution actually is not 95, it's 97.5 because 95 in the middle, right? So 2.5 at both ends. So it's 97.5, but more or less it's right. I mean, at least top 95%, right? So you're 2SD, then you're pretty safe, right? And of course, actually, you are 2SD in the high school, right? Otherwise, you can't really get into CHK, right? So you're very good already. And to be very good among very good is very difficult, right? So that's why to get an A is not that easy from our class, but I think it's doable. Speed is okay, I guess. We're not very fast. Overall, everyone is not too bad. Okay, so this is a new question. As I promised last class, I think asking you how tired you are, and you're very tired. So everyone strongly agree you're very tired. Okay, luckily it's Friday, and I don't think we don't have some major class in the afternoon. I hope, and then you can take some rest. Uh, Taking rest is very important. And as far as you know, right, your brain is still growing. Although you are 20 something, right, 80 around 20s, but your brain is still growing. You don't have enough sleep, your brain doesn't grow very well. So if you want to become smarter and smarter and smarter, then take enough sleep. Um, Tired. Finally Friday, yes. How far do poor people go when they wash their face? I don't know. I don't know. May I ask you to write reference letter? Well, I can only write if I know you, but if I don't know you well enough, then just send me your CV, then say hi to me before, right? At least I know you before I write to you, right? At least say hi to me or email me, right? Or at least I can't remember your name, but at least you send me your picture so I know. I mean, I can remember your face, but at least and I know who is who, right? Because I don't put the name tag, so I don't know which one is you, right? So if you want me to write, it's fine, but at least let me know I saw you in the class, right? Right? Or at least you show me that based on your send me your assignment, or at least I know you submit your assignment, right? So that I know more about you. I mean, it's fine. I mean, usually I write, there's no problem. Um, there are 10 people, type people in the world, those who understand binary, those who don't. Okay. How many past people? I think one is enough because they're very similar. But you can always ask previous cohort because every year I release the last year. Okay. And I think you can see the past paper is easier than your assignment, right? So if you really want exercise, let's do the assignment is the better, right? Because for your practice. Oh, that's a good one. What did 20 do when it's hungry? 28. Okay, that's a good one. I think we haven't seen joke quite a while. I mean, joke is actually keep us awake. That's what I do. When I was very tired, I ask my AI, tell me a joke, and then I get happy. Hopefully, you can try that as well. No, okay. So I hope that would be useful. Tips for you. Um, so for the remaining time, I will just very quickly skim over chi-square T and F because we'll use them again, but just let you know there's something there. Okay. Well, quickly, what's chi-square? Chi-square is just x square, and basically just z square. Basically, you have a bell, standard bell, and square. That's chi-square. So let me write down here was chi-square. So chi-square is the following. You have a bell, this, sigma is 1, right? What you do is you pick a number here, okay? Pick a number and square it, okay? This gives you the chi-square, okay? The chi-square will look like this, okay? Why? Because you square, right? The minimum is 0, right? Actually, in your slide as well, right? So this chi-square is just normal square. And you ask why you have chi, right? Why was chi? Because in the old days, I don't know now, in old days, the printing is not a printer, right? But you have to someone to pick up the stamp for each letter. And in the old days, they can't distinguish chi and x. They're confused. That's why supposed to be x square, but turn out by mistake, it become chi square. So that's history. Okay. This is chi square is you draw the bell, normal bell, and square it. Okay. Because square, it must be positive, right? So chi square is from 0 to infinity, right? There's no negative. Okay. And you ask, what is this one? And chi-square later, we'll talk about is the distribution of the variance, sample variance. Okay, the sample variance will follow a chi-square. We'll talk about this a little bit more. And you don't just do one square, you do more square. So you draw two number, one number is square, draw another number is square, add together. Then we chi-square 2. Chi-square with degree 3, you withdraw 3 number, each square each one, and add together. That will chi-square 3. So that's what I write in the slide over there. Okay, you will see what it is. It's actually the ideal variance. So square, 1 normal square, 2 normal square, up to n normal square will be chi-square n. So just need to know this statement. That's enough. Okay, because we'll be using, you will know it. Okay, and we don't do it right now. And this chi-square is used to statistics, right? So we will be using for the second half of the course. And chi-square will not, in our class, we will not use it directly. It can be used directly, but in our class, we skip it. You can check the textbook. There's some way to use it, but we will not use it directly. Rather, we'll use it what we call the, this what it looks like I mentioned already. Okay. We'll use it for T distribution. Okay. And what is T? T is a very funny thing. It's the fraction. The numerator is the bell, and denominator is chi-square. Okay, so you may ask, what is it? What is it doing? Okay, and first I tell you what it looks like. This is just a bell curve, but a fatter bell curve. Okay, let's see the next slide. You look at a bell. Okay, the brown one is a normal curve. The T will be the red, the blue, and the green, much fatter. Okay. At the end, of course, much shorter at the center. Okay, this is the bell curve. This is the T. And then you ask why we care about this one. Very soon you will see the T distribution is actually capturing the sample mean. Okay, we'll talk about this next week. Okay, and the sample mean will actually follow the T distribution. Okay, and you will ask what's M. M later you will see that is actually related to sample size. M is actually n minus 1. The sample size minus 1 will be M. Okay, and you will see this M when it is more than 200. Okay, which usually apply in your sample, right? More than 200. That's not much different from normal. So that's why at the end, the normal bell curve would be applying for many things. Okay, so that's why we'll be doing that. Don't worry. This kind of T, we will talk about this 1 week or 2 weeks later. So we'll see it again. Again. This is something that we will do. So don't worry too much about this at this moment. Just let you know. Later, we'll come back to this guy. And this guy, student T, the T is just a normal. It's a very similar to normal, but a fatter one. And you may ask, what's the meaning of the T? T is actually invented by a American statistician. But his name, of course, is not T. It's a Wasset. And he worked for a company called, I think, General Electric or General Motor. I forgot. General Electric, I think. And he can't publish his thing without his company approval. So he published this result under the pen name called student. And student, the last word is T, right? Student, right? So that's why it's called T distribution. Sometimes you look at the textbook, they call student T distribution. Okay, that's the students come from. It's not because it's for student, but rather he used a pen name called student. And lastly, you have an F distribution is comparing two chi-square. Okay, as I said, chi-square is looking at the variance, right? So F is comparing two different variants. Okay, and you ask why we care about that. Later you will see when we try to compare two different stock, are they having the same risk, right? Or different risk? Then F will be saying you look at, right? You look at the variance of one stock over the other, then this ratio will follow the F distribution. Okay, and then you can see later the test whether they're same or not the same. And F is very useful. It's actually what we call the ANOVA, analysis of variance, and which is also the last question in the last year exam, right? And what is ANOVA? ANOVA is the idea that you try to understand the variance, right? And why we want to study, why do we want to compare variance? Is because we want to understand the usefulness of a model, right? How you assume there's a model behind, okay? And your model should help you to do some prediction, right? And you should reduce the prediction mistake, okay? And mistake is measured by error, right? So the variance, right? So you compare the case, you have a model, you have a variance, you have a model, you have variance, no model variance. And you should expect the model, under the model, the variance is smaller. You should predict more precise, right? Then that's why you compare variance. So you compare the performance of two models, right? Or you compare the performance of model and without model, right? The one with model or better model should lead to less error. Less error means less variance, right? So that's why we talk about that. So don't worry about this kind of thing because I just talk about this at the moment at the high level. We'll go into very detail, then you will know what's going on. For the last week, chi-square, T and F, I just tell you what they are. You don't worry about this because it's not supposed to belong to this set of slides, but I just put it there because it nicely is here. But we will use it and then you know what's going on later. Okay? Is that a question? No, good. Then we're done with this. Now we go to Excel. Okay, Excel very quick. For the last 15 minutes is sufficient for doing that. Okay, we teach you, then we'll cover this Excel, then you can go home and do every part of the assignment, right? Because the assignment that currently missing is the Excel. So what we're going to do is tell the Excel function to give you the P and the F, right? So the only thing Excel can help you, right, is to give you the P function and F function, right? Let me go to, not going to slide by slide, but rather I'll go to the calculation part and tell you that how this thing can be done, right? So I go back to the binomial slides. and tell you that how you can do it quickly. So this question, if you remember, restaurant owner, each customer have 30% the guy who likes spicy food, right? And ask 5 new customer, 2 of them like spicy food. Okay. Then you can do this calculation, but I want to show you, use the formula, can give number directly. Okay. Let me show you. Okay. So what we have is binomial. Okay. Then we have N and P, right? N is 5, P is 0.3, right? So this is the question. And we are asking ourselves, what is P of 2, right? Is the probability exactly 2, right? Of that. So this is what we have. Okay, P of 2. So what is the formula to do that? Okay, we'll be using the equation, Excel input called binom dot dist. Okay, binom dot dist. B.B.A. binom dot dist. Okay, binomial distribution. And then you input numbers, which is 2. Number of trial is 5. Probability is 0.3. And this function contain big P and big F. They ask you whether cumulative is the P, then it's false. Okay, use. So this is how you get the answer. Okay, so that's quickly the calculator can do that. Of course, if you don't like this, you can do directly, right? So if you don't like that, you can do 5C2, 0.3 with the power 2. And then 0.7 raised to power 3. Okay. If you don't like that, you can do that as well. Right. So either the way you do the same, right? Because this is the formula in the slide. Is that clear? So this is how we get the binomial. Is that okay? Let me save this file on the desktop first. Okay, so this is the P. And you do notice the question also asks in the next slide is less than or equal to 2, right? Your customer less than equal to 2 customer like spicy food, which is F of 2, right? So we can do the same, but change from false to true, right? So the question is F of 2. So the formula will be simply that the last one is false to true. So what this guy is actually P1, P0, P of 0 plus P of 1 plus P of 2, right? So this is already, if you remember the slide, it's just here. It's P of 0, P of 1, P of 2, right? If you use calculator, your life is terrible, right? Add 3 times, right? Not that bad, but you still have to input many times. But if you know this actually F function, then just this and then you're done. Is that clear? How we can do it? Okay. Don't worry, you will be using. I'm asking you to do Excel input for each question in your assignment, so you must know it. Okay. Is that a question? Is that okay? It's already in your slide, but if you want, it's already why this formula here is already in your slide, but let me show you it again. It's here. Okay. This P, this F, right? It's N, X, and P, right? Is that clear? It's already there. Okay. So in case it's okay, then will not be difficult to draw Poisson. Poisson even simpler, right? Because Poisson don't have NP, just one lambda. Okay? Just we put X and lambda. For the P is false. For the F is true. So let's directly show you how to do it from our exercise. Let's go back to our exercise for the Poisson. Okay. The Poisson is saying each hour, 5 customers there. What is probably exactly 2 comes in. Okay. So let's see how we do that. Okay. Again, this binomial. Let's do the Poisson. And Poisson only one thing, lambda. And lambda is 5. We're asking exactly 2 customer comes in, right? So we're asking P of 2. And the formula is just Poisson dist. And X is 2, mean is 5. And for the P, it's always false, probably mass function. So that is that's number you saw in the slide. Okay. So is that okay? Just wait 1 minute. This Excel spreadsheet I'll upload to the Blackboard. So don't, if you don't have time to, you can check it out. Okay. Unless the computer die, the file is lost, but otherwise it should be there. And as I said, our class are record. So if in case you lose, go back to the video and check it out, right? It's something you don't have to worry too much. Okay. Now, although I didn't say it, but you can easily see if I ask you the probability that less than or equal, maybe more complicated, right? Or asking what's probability that less than or equal to 2 customer would come, right? So P equal to 0, 1, 2, 3, right? How can you do that? Then it's just F of 2, right? Okay. So if you do that, what we get is this probability that there will be 0 customer comes in, 1 customer come in, or 2 customer come in. Is that okay? So this is how you can do the Poisson. Is that okay? Hmm? Oh, this is, we don't have F in the, we don't ask this one, but this is answering the question same as the F, as because F of 2 is saying P of 0, P of 1, and P of 2, right? It's asking, if I ask a question, what is the probability that less than or equal to 2 customer would arrive in next hour, right? And that will be following this answer, because that is what is the meaning of F, right? Less than or equal to that number. Okay. If we're done with Poisson, I want to show you the hypergeometric, right? Which is NAN, NNA. And why are you NNA? Because this is exactly, if you go to the slide of hypergeometric, hypergeometric is NAN. Okay. So this is a question, right? In the warehouse, you have 30 items. Out of that, 4 are defective. You draw 6 items. You ask the probably 2 of them are defective, right? So that is the example that we have go over in the class, right? So let's write that down. Right, so we have N is 30, A is 4, small n is 6, and then x is 2. So there's a question. We're asking P of 2, right? And look at this is small n a n, right? So this is exactly n a n. So you input from the above, right? 2, 6, 4, 30. Sorry. So will be 50% of the time you will see 2 objects there. Okay. So that is what we have, right? So there's a minor point that I want to mention a little bit is what happened with the f of 2. Okay. So f of 2 is 98%. What does that mean? It means that if this is the right information, 98% of time, you should only see defective product no more than 2, right? And means, what does that mean? It means that if you do the audit, you check that you have 3 or 4 defective item or more, right? Out of the 6 sample you got, okay, you can have 3, 4, 5, 6, right? Because you check 6 item, okay? Right? Actually, you cannot go more than 4 anyway. You have 3 and 4 defective item. And in that case, you would think this is unlikely to be true, right? Because 30 is the thing that is objectively how many items in the warehouse. And 6 is your decision, how many to check. X is your outcome. 4 is given by your client, right? And if it turns out that, okay, you have 3 defective item or 4 defective item, then basically you think it's so unlikely. Then you actually think the client is telling you a lie, okay? Or you don't believe that you can't verify it because you think the claim is so unlikely. And that is the basis of why you do audit, right? That is the calculation behind you do the audit. It's so unlikely. This A is actually 4, okay? So that is the reason why hypergeometric is used in audit. That's why you need to learn audit when you do probability. Sorry, why you need probability for accountant, right? Otherwise, how can you judge whether the 4 is right or wrong, right? You can only do sampling, right? You go to a warehouse, check out the item, and you can only verify whether A is likely or not likely. We'll talk about this hypothesis testing later, but this is the main idea behind. You assume what's right and look at the data, okay? So this hypergeometric, okay? And once with that, then we talk about exponential. So exponential is like this, is 1 over lambda, okay? And remember, for continuous, you only care about the f, right? You don't care big F, you don't care about the small f, right? Because the small f is no use for us. exponential. Lambda is 20. And f of 10 will be 10. So this is our exponential calculation, right? This corresponds to the question we have in the example. Here, right? 20, 10.93. Okay. So before we end, we tell you the most important part, normal. Maybe I go to standard normal first. Because this is the table, right? We have Z is equal to 1. Okay. Then we want to know the F of that. That's the C table. We have that. So just give me 1 minute, then we're done. Okay. Just after this. Yes. Norm, standard deviation distribution. And you put 1 here. And as I said, for contiguous, you always go for the true. Okay. And this is exactly the C table you see. Okay. So basically, with this, you can do your assignment. Let's start. So this is the guy. Okay. This is the normal. You can always convert to Z, then you can always use norm as this B7. Not maybe not B7, I just put 1, right? That's better. Okay. If you put -1, also do the same, right? But I don't want to, you can change the number there. Okay. I guess I don't want to keep you because many of you have things to do afterward, but that's sufficient for your assignment. Okay. So I will see you next week. Enjoy. I know you're very tired, but our assignment have 2 weeks, so you don't have to worry too much. Okay. I'll see you next week.